We are going to start now the next lecture, lecture 3 of chapter 3, class 10th mathematics. It is pair of linear equations and two variables. In this lecture, we are going to discuss about the method of cross multiplication and some conditions related to the consistency of the solution of the linear system of linear equations in two variables. First we have, it is the method of cross multiplication. So we are saying we have two equations over here, and one equation we are saying it is ax plus, this equation we are talking about, it is a1x plus b1y plus c is equal to 0, and second is a2x plus b2y plus c2 is equal to 0, and this condition is given to us that a1 over a2 is not equal to b1 over b2. Then we are saying that this system will have a unique solution. The more detail of this condition we will study in our some next slides. So this is basically the condition for the unique solution, that if this condition is satisfied, then this pair of linear equation or system of simultaneous linear equation, it has a unique solution, and that solution is given by this formula, that the value of x is given by this value and value of y is given by this value. You can directly apply these values as the formula. How we are getting these values is, we are saying one equation is a1x plus b1y plus c1 equal to 0. Second equation is a2x plus b2y plus c2 is equal to 0. In the first case, we are saying we are multiplying this equation with, say, a2, and we are multiplying this equation with a1. So our system of equations becomes a1 a2x plus a2 b1y plus a2 c1 is equal to 0. Second is a1 a2x plus a1 b2y plus a1 c2 is equal to 0. When we subtract these values, we are saying this term gets cancelled. From this we are getting, it is a2b1 minus a1b2, this is 2 over here, times y. If we send these terms on this side, what we get is, it is a1c2 minus a2c1. So the value of y we obtain, it is a1c2 minus a2c1 over a2b1 minus a1b2, and same thing is can be written as, it is c1a2 minus c2a1 over a1b2 minus a2b1. So this is the value of x that we get. Similarly, in place of this a2, we multiply this equation with b2 and this equation with b1, we will get this value of x. So how we can remember these values, these two values we are talking about? So we are saying these are the two equations that we have. These are the two equations that we have. So we are writing the answer in this form, that it is x over y over and 1 over. Basically it is minus y over. So what we have to do is, when we are writing this term x over, so what we are going to do, we will leave these two terms. We are writing the terms in the denominator of x, we are leaving these two terms. So the coefficients we are left over here, it is b1, b2, c1, c2, and we cross multiply these values over here. We are saying it is b1, c2 minus b2, c1. Next, when we are talking about this term in the denominator of minus y, this is minus sign over here. So what we are going to do, we are going to leave this term And what we are left with is, we are left with this a1 c2, it is a1 c2 minus a2 c1. Now the next term that we have to write the term in below the constant term. So we are leaving this third term over here. We're talking about this c term we are seeing. Now the coefficients we have, when we cross multiply these values, we are having it is a1 b2 minus b1 a2. Now when we compare this first value with this last value, we can calculate the value of x. We are writing these two equations, so we can write the value of x from this equation. So the value of x that we will get, it is b1 c2 minus b2 c1, this term we are talking about, divided by, it is a1 b2 minus b1 a2. Similarly, if we use these two values, we can calculate the value of y, and we will get the answers in this form. This is the value of x that we have obtained. This is the value of y that we will obtain. This is one of the methods to write this. Second method is, you can write the given equations in this form. We are saying we are writing it is x, y, 1. Then leave these first terms over here and start from this second term, that is with the coefficient of y. We are talking about, we will start from these coefficients of y, and we have written it is b1 b2. Next we have written the constant term c1 c2. Next we have written the term a1 a2. Next we have written the term b1 b2. Then what we are going to do, we are going to cross multiply these terms. It is shown over here that b1 and c2 is multiplied, that b2 and c1 is multiplied in the denominator of x. These terms are there. Then in the denominator of y, we are saying we are multiplying c1 and a2. It is c1 and a2. Then minus sign is there. This minus sign is important over here. And then the next term we will have it is c2 a1. Next, in the denominator of 1, it is a1 b2 minus a2 b1. So you can use any of these procedure. You can either use this procedure or you can use this procedure. It is up to you that how you want to calculate these values, but the final answer that you will get, it is x is equal to this and y is equal to this. So it is up to you that how you want to calculate these values. So this procedure will be more clear to you with our next examples. So we are saying we are given a system of linear equation. This is first equation, this is second equation. So if we look at write these equation like this, it is 2x plus 3y equal to 17, and second is 3x minus 2y equal to 6. So what we are talking about, two procedures over here. First is we are writing x, y and 1. Then we are leaving these terms of x. Now the coefficients we have over here 3 and 2. These are the coefficients over here. It is 3 and this 3 and this is minus 2. Then it is, when we send this term on this side and we send this term on this side, we get the equations in this form. First of all, we will have to write the equations in this form. Then we have the next terms over here. It is minus 17 and this term we have it is minus 6. Next we have to write the coefficients of x. So it is 2 and 3. This is 2, this is 3. And then we have to again write the coefficients of y. So these coefficients we are saying these are 3 and minus 2. So how we are going to write the answer? And in below x we are going to write these two product of these two terms, that is 3 into minus 6, 3 into minus 6 minus, we have to write the product of these two terms, it is minus 2 into minus 17, that is equal to y over, we have to write the product of these two terms, it is minus 17 into 3 minus 2 into minus 6, 2 into minus 6, and last term we are going to write it is, this is equal to 1 over, and the last term that we have to write 1 over means we are talking about it is 2 into minus 2 minus 3 into 3. So these are the values mentioned over here, that these are these values. So when we compare, when we solve these values, you will get the answer in the form, we have simplified these values and we are getting the answer in the form x over minus 52 is equal to y over minus 39 is equal to 1 over minus 13. So when we compare this first and last term, we get x is equal to minus 52 upon minus 13, and that is equal to 4. When we compare this second and this last term, we are getting y over minus 39 is equal to 1 over minus 13. So we get y is equal to 39 by 13, that is equal to 3. So these are the required answers, that x is equal to 4 and y is equal to 3. So these are the required answers. Similarly, in this next question, we are having two equations of the form, it is 4x minus 7y plus 28 is equal to 0. Second is 5y minus 7x plus 9. So we have to write this equation in the form, it is minus 7x plus 5y plus 9 is equal to 0. So one of the methods we have to write x, y and 1. These are the coefficients of y. These are the coefficients of x. These are the constant terms and these are the coefficients of y. Then it is x, y and 1 over here. Under x it is minus 7 into 9 minus 28 into 5. Next it is 28 into 7 minus 9 into 4, and last it is 4 into 5 and minus 7 into minus 7. These are the values we are getting by these terms over here. This is cross multiplication of this is cross multiplication of second, and this is by cross multiplication of this third term. And we will solve these values, we will get x over minus 203, y over minus 232, and that is equal to 1 over minus 29, and we get these two values of x and y. The second method we are talking about, it is how we can write the answer for this. It is x upon minus y upon and 1 upon. We need not to write the equations in this form, we are directly writing from these equations. So when we are writing the terms corresponding to x, it means we are leaving these two terms. Now the coefficients over here we have, it is minus 7 into 9. We are saying it is minus 7 into 9 minus 5 into 28. We are talking about this term over here, it is 5 into 28. Next, under y, when we have to write, we are leaving these two terms. What we are left with is, it is 4 into 9 minus minus 7 into 28. So it is 4 into 9 minus minus 7 into 28. We get this value. And the last term we are talking about, when we are talking about the constant term, we are saying we are leaving this term over here. We are leaving this term. And the coefficients we are talking about, it is 4 into 5 minus minus 7 into minus 7. So if we compare these values with this formula, we see that this term below x, it is same over here. Over here we are writing y, and over here we are writing minus y. That is the difference of these signs are. That the term we have over here, it is minus 7 into 28. We are talking about this value over here. It is minus 7 into 28. This term is over here. When we are talking about 9 into 4, this term is over here. And this negative sign is already there. And the last term, when we are looking at the last term over here, this is also same. So again we will get the answer as x is equal to 7 and y is equal to 8. Now next it is 2 over x plus 3 over y is equal to 13. So this is not a linear equation, so we are saying we have to convert this to the linear form. So to convert these equations in the linear form, we know the substitution that we have to do is 1 by x is equal to u and 1 by y is equal to v. So these equations will come in the form 2u plus 3v minus 13, and this is 5u minus 4v plus 2. So these are the two equations. When we substitute, 1 by x is equal to u and 1 by y is equal to v. So for these equations, again we can write the answer as u, v minus v and 1. In the denominator of u, we are saying the equations we have, it is 2u plus 3v minus 13 is equal to 0. It is 5u minus 4v plus 2 is equal to 0. So when we are writing the terms corresponding in the denominator of u, it is 3 into 2. We are talking about this minus 13 into minus 4. So it is 3 into 2 minus 13 into minus 4. And we are writing the term in the denominator of minus v. So it is this term we are talking about 2 into plus 2 minus 5 into minus 13. And last term when we have to write, we will leave this term over here, and what we are left with is 2 into 4. We are talking about this term over here. This is 2 into minus 4 minus, it is 5 into 3. So when we solve these values, you will get it is u over minus 46 minus v over 69 1 over minus 23. Look at this term, u over minus 46 and 1 over minus 23. So what we get is u is equal to minus 46 by minus 23, that is equal to 2. Similarly, if we compare these two values, we get v is equal to 69 over 23. So answer we are getting it is 3. So these are the value we are talking about, that u is equal to 2 and v is equal to 3. Now what we have substituted, we have written this is equal to 1 by x and this is equal to 1 by y. So the values of x we have, it is 1 by 2, and the value of y we have, it is 1 by 3. Next is we have to solve this equation by cross multiplication method. If it is not mentioned in the question, you can use any of the methods, but over here we are using the cross multiplication method. So again the equations we have, it is ax plus by minus c is equal to 0, and then it is bx plus ay minus 1 plus c is equal to 0. You can use this method. You can write x, y and 1, and these are the coefficients of y, these are the coefficients of y, these are the coefficients of, these are the basically constant term, these are coefficients of x, again these are coefficients of y. So you can use this method, or what you can do, it is x over minus y over, and it is 1. When we are writing x over, it is b into minus 1 plus c minus a into minus c. Similarly, for the terms in the denominator of minus y, we have a into minus 1 plus c minus b into minus c. We are talking about this term into this term, this term into this term. In the first step, we have multiplied these two, and we have multiplied minus these two. And in the denominator of 1, we will have a square minus b square. So same terms we are getting by using this method. Both the terms, they are same. So on solving these values, when we compare this first and last, you will get the value of x is equal to c into a minus b over a square minus b square. On comparing these two values, we are talking about these values. This is value of y, and this is the constant term. The answer we will get, it is y is equal to c into a minus b plus a over a square minus b square. Next is condition for solvability of linear equations. So we already know what is consistent and inconsistent system. Consistent means it has solution, maybe finite. Finite means we are talking about it is unique or infinitely many. And inconsistent means it has no solution. So we are saying a system of equation a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0 is said to be consistent if it has at least one solution, and if it has no solution, it is called inconsistent. So the condition for consistency, these are given over here. We are saying if a1 over a2 is not equal to b1 over b2, then the system will have unique solution. These are the equation, system of linear equations that we have. This is the system. We are saying if a1, this a1 over a2 plus b1 is not equal to b1 over b2, then the system will have a unique solution. And the solution we have seen in our previous slide, that the solution is given by this formula. Next we are saying, if suppose these two values, these are equal, a1 over a2 is equal to b1 over b2, it means it doesn't have a unique solution. So next thing we have to do is we have to compare it with c1 over c2. If all these three values, these are equal, then the system will have infinitely many solutions. These are the two cases for consistent. And if this is the third condition, if a1 over a2 is equal to b1 over b2 and not equal to c1 over c2, this third condition we are talking about, then we are saying the system has no solution, that is, it is inconsistent. The similar kind of things we have also discussed when we are talking about the graphical solutions. So over there what we were saying, that if the two lines they intersect at a point, then that is the case of the unique solution. If the graph we get, these are, there is only one line over here, that both the line they overlap, then it has infinitely many solutions. And if two lines they are parallel to each other, then the system is inconsistent, that is there is no solution for this system of equations. Now algebraically we have three conditions over here. First is for consistent, it is a1 over a2 should not be equal to b1 over b2, then it has a unique solution. If a1 over a2 is equal to b1 over b2 is equal to c1 over c2, then it has infinitely many solutions. And if it is not equal to c1 over c2, then it has no solution. So this is the problem based upon this, that this system of equation is given and we have to show that this system of the equation has a unique solution and we have to find that solution. So if we look at these values, this is the value a1, this is b1. Now what we have to do, we are not saying this is the value c1, we have to write them in the form a1x plus b1y plus a c1 is equal to 0. So when we write this equation in this form, it is 2x plus 5y minus 17 is equal to 0, and it is 5x plus 3y minus 14 is equal to 0. This is the value of a1, b1, c1, a2, b2, c2. So what we have is a1 over a2, that is 2 by 5, b1 over b2, that is 5 by 3. So what we have is that a1 over a2 is not equal to b1 over b2, and this is the case when, for this case we have it is, this system will have a unique solution. To solve this system we are using the cross multiplication method, and we are writing the answer as x over 5 into minus 14 minus 17 into 3, that is equal to minus y over, it is 2 into minus 14 minus 17 into 5, and 1 over, it is 2 into 3 minus 5 into 5. We are talking about, we are multiplying these two in the last, then for the first two terms it is 5 into 14, and for the middle term it is 2 into minus 14, 5 into minus 17. When we solve these values, we are getting the answers in the form that it is x over minus 19 is equal to y over minus y over 57 is equal to 1 over minus 19. So this gives us x is equal to 1 and y is equal to 3. How? We are comparing this first and last term. We are getting x over minus 19 is equal to 1 over minus 19. So we get x is equal to 1. When we compare these two terms, we will get y is equal to 3. Now the next question we have to find the value of k for which these system of equations, they have a unique solution. Now if this system has a unique solution, so it is a1, b1, a2, b2. So the condition we have it is a1 over a2 should not be equal to b1 over b2. So a1 is 1 over a2 is 3, b1 is minus 2, b2 is k, and we are saying that these two should not be equal. So this implies us that k should not be equal to minus 6. So what condition we are getting from this, that if k is not equal to minus 6, then a1 over a2 is not equal to b1 over b2. So it means that this system of equation will have a unique solution for all real values of 6 of k other than minus 6. That is, except for minus 6, if k will have any other value, then this system of equation will have unique solution. Next is show that the system of equation, this system is given, this is one equation, this is second equation, it has infinitely many solutions. So we are comparing the coefficients over here. This is a1 b1, this is minus of c1, this is a2 b2, this is minus of c2. Why I am writing minus of c1 and minus of c2? Because we have to convert these equations to the form 4x plus 6y minus 7 is equal to 0. Then it is 12x plus 18y minus 21 is equal to 0. So what we get? It is a1 b1 c1 a2 b2 c2. Now the condition we have is that this system has infinitely many solutions, and for infinitely many solutions we are saying a1 should be equal to a1 over a2 should be equal to b1 over b2 is equal to c1 over c2. So what is a1 over a2? It is 4 over 12, that is equal to 6 over 18, that is equal to minus 7 over minus 21, and all these values, these are equal to 1 by 3. When you simplify all these values, you will get the answer is 1 by 3. So what we are saying is that a1 over a2 equal to b1 over b2, that is equal to c1 over c2. So this system has infinitely many solutions. Next is this system of equation is given to us. This is one equation, this is the second equation, and we have to find the values of k for this system to have infinitely many solutions. So we have written them in the form such that this constant term is on the left hand side. So the equation changes to this form. Similarly, in this equation, when we are moving this side over here, the equation changes to this form. Now what we have, this is the value of a1, this is b1, this is c1, this is a2, this is b2, and this is c2. Now it is given that the system of equation has infinitely many solutions. So if this system has infinitely many solutions, so what we have is that a1 over a2 should be equal to b1 over b2 should be equal to c1 over c2. So we get it is 2 over k plus 1, that is equal to minus 3 over 1 minus 2k, that is equal to minus 7 over 4 minus 5k. We are writing these three equations over here. So what we get is, suppose we are considering these two equations separately and we are considering these two equations separately. So what we have is, from first two equations we are saying it is 2 over k plus 1, that is equal to 3 over 2k minus 1. Second is 3 over 2k minus 1, that is equal to 7 over 5k minus 4. So when we cross multiply, we solve these equations. So we get it is 4k minus 2 is equal to 3k plus 3, and it is 15k minus 12, that is equal to 14k minus 7. From this we get the value of k is equal to 5. From this we get the value of k is equal to 5. So we are saying for k is equal to 5, the given equations, they are having infinitely many solutions. Next we have, it is find the value of k for which the given system of equations has infinitely many solutions. So we are writing these equations in the form, it is kx plus 3y minus k minus 3 is equal to 0. Next it is 12x plus ky minus k is equal to 0. So these values we are saying this is a1, b1, c1, this is a2, b2 and c2. So a1 over a2 should be equal to b1 over b2 should be equal to c1 over c2. So suppose we are solving these two, we get k square is equal to 36. So the value of k we get it is equal to plus minus 6. Next, if we are considering these two equations, on solving these two we get it is 3k is equal to k square minus 3k. So this is k square minus 6, k is equal to 0. So it is k into k minus 6 is equal to 0. So we are saying k is equal to 0 or k is equal to 6. So what is the common value of k that is satisfied? From this we are saying k is equal to plus 6 and minus 6. So the common value we have over here it is 6 and 6. So we are saying the given system of equations has infinitely many solutions when k is equal to 6. Next is find the value of k for which the given system of equations has infinitely many solutions. So again we have the value of a1 is this 1, this is b1, this is c1. We have to send it over here, so it is minus of c1. So when we are writing the condition for infinitely many solutions, you know that the condition is that a1 over a2 is equal to b1 over b2 should be equal to c1 over c2. Now what is value of a1? It is 1. What is value of a2? It is k plus 1. The value of b1 is k plus 1 and the value of b2 is 9. Then the value we have it is minus 5 over 1 minus 8 k. This is the value of c2. This is b2. This is minus of c1. Now we have to solve these two equations. So on considering the first two, we get 9 is equal to k plus 1 square. So we are saying k plus 1 is equal to 3 or k plus 1 is equal to minus 3. So we get k is equal to 2 or k is equal to minus 4. This is from the first two equations. From the next these two equations we are saying it is k plus 1 into 1 minus 8k that is equal to minus 5 into 9. When we multiply these terms it is k minus 8k square plus 1 minus 8k that is equal to minus 45. So this equation becomes 8k square plus 7k minus 46 is equal to 0. So by splitting the middle term we get it is 8k square plus 23k minus 8k minus 46 is equal to 0. So on solving this we are writing it is not 8, it is 16k over here. So it is 8k square minus 16k plus 23k minus 46 is equal to 0. From these two terms we can take 8k common and we are left with this k minus 2. From these two terms we are taking 23 common and we are left with this k minus 2. So the final answer we will get it is k minus 2 into 8k plus 23. So this gives us k is equal to 2 or k is equal to minus 23 by 8. Earlier we have k is equal to 4, minus 4 and k is equal to 2. So the common value we have it is k is equal to 2. So we are saying for k is equal to 2, this system of equation, this will have infinitely many solutions. Now in this question, the system that we have, it is 2x plus 3y minus 7 is equal to 0, and it is a minus bx, a plus by minus 3a plus b minus 2 is equal to 0. Again we are given that it has infinite solutions. So for infinite solution, the condition we have, it is a1 over a2 should be equal to b1 over b2 should be equal to c1 over c2. So it is 2 over a minus b should be equal to 3 over a plus b should be equal to minus 7 over minus of 3a plus b minus 2. By considering the first two terms, we get it is 2a plus 2b is equal to 3a minus 3b. So this gives us that 5b is equal to a. We are talking about this value over here, that 5b is equal to a. Now if we solve these two equations, we are having this minus sign gets cancelled over here, and we are having it is 9a plus 3b minus 6, that is equal to 7a plus 7b. So what we get is that 2a, this 7a terms we send over here and this term we send over here, so it is equal to 4b plus 6. So a is equal to 2b plus 3. So we are saying we require such values of a and b which satisfies both these conditions, that is a is equal to 5b and a is equal to 2b plus 3. So by comparing these two values, we get 2b plus 3 should be equal to 5b equal to 3b. So this gives us b is equal to 1, and this gives us a is equal to 5. So we are saying these are the two values, that is a is equal to 5 and b is equal to 1, which satisfy both these equations. So this is the required answer, that a is equal to 5 for a is equal to 5 and b is equal to 1. This system will have infinitely many solutions. Next is find the values of m and n for which the following system of linear equations has infinitely many solutions. So now over here these equations are 3x plus 4y minus 12 is equal to 0. It is m plus n into x 2 into m minus ny minus 5m minus 1 equal to 0. Again this system will have, we have given that this system should have infinite solution. So condition is a1 over b1 should be equal to b1, a1 over a2 should be equal to b1 over b2 should be equal to c1 over c2. So we get it is 3 over m plus n, that is equal to 4 over 2 into m minus n, that is equal to minus 12 over minus 5m minus 1. This minus sign gets cancelled, this 2 gets cancelled. So on solving these two terms, what we get is 3m minus 3n, that is equal to 2m plus 2n. So we get m is equal to 5n. On solving these two equations, we have, if we cross multiply these terms, we have 10m minus 2, that is equal to 12m minus 12n. So if we solve this equation, we get 12n minus 2 is equal to 2m. So the value of m we obtain, it is 6n minus 1. For solving these two equations, we are saying that both these m should be same. We are saying we are solving these two simultaneous equations. So we have 5n is equal to 6n minus 1. So we get n is equal to 1. Send this term on this side, this term on this side. We get n is equal to 1. So the value of m we get, it is 5. So we are saying that for m is equal to 5 and n is equal to 1, this system of equation, simultaneous equations, this will have infinitely many solutions. Next question we have, show that the system of equation has, these are the system given, and we have to prove that this has no solution. So we are writing this equation in the form 3x minus 5y minus 7 is equal to 0, and it is 6x minus 10y minus 3 is equal to 0. So these are the values of a1, b1, c1, a2, b2, c2. So what we get is that a1 over a2, that is equal to 3 by 6, b1 over b2, that is equal to minus 5 by minus 10, and c1 over c2, that is equal to minus 7 by minus 3. So this value is 1 by 2, this value is 1 by 2, and this value is 7 by 3. We are saying a1 over a2 is 1 by 2, b1 over b2 is 1 by 2, and c1 over c2 is 7 by 3. So what we get is that a1 over a2 is equal to b1 over b2 is not equal to c1 over c2. So this system of equation has no solution. Next we are saying find the value of k for which the system of equations this has no solution. These are the two systems that are given to us. So it is x plus 2y minus 5 is equal to 0, and second is 3x plus ky minus 15 is equal to 0. So we are saying that 1 over 3 should be equal to 2 over k should not be equal to minus 5 over minus 50, because the system has no solution. So this sign is there. So from this we are getting it is k is equal to 6, and this value we are saying it is 1 by 3. So what we see from this is that if we solve these two values, we are saying it is 2 over k should not be equal to 1 by 3. So it means k should not be equal to 6. So we are getting two values over here. In one we are saying that k should be equal to 6, and one we are saying that k should not be equal to 6. It means no such value of k is possible. No such k is possible, such that k should be 6 and k should not be 6. So answer we are giving is there is no value of k for which the given system of equation has no solution. There is no value of k over there. Next is find the value of k for which the pair of linear equations this and this has no solution. So it is kx plus 3y minus k minus 2 should be 0. Then it is 12x plus ky minus k should be equal to 0. Now we are saying that the system has no solution. It means k over 12 should be equal to 3 over k should not be equal to minus of k minus 2 over minus of k. From these two we are getting that k square should be equal to 36. It means either k is equal to plus 6 or minus 6. Now if we are considering these two equations, then what we get is that these two negative sign, these get cancelled. So we get it is 3k is equal to k square minus 2k. This gives us k square minus 5k is equal to 0. K we take common, it is k minus 5 is equal to 0. So we are saying k is these values, these are not equal to 0. So we are saying k should not be equal to 0. K should not be equal to 5. So what we are saying from this is that first thing we obtain is that the value of k can be plus 6 or minus 6. Then we have and in between these two conditions, and k should not be 0 and 5. So it means these are the two values of k, that if k is equal to 6 or minus 6, then this system of equation will have no solution. Next is find the value of k for which the pair of linear equations has no solution. So these are the two equations that are given to us, and we have to find the value of k for which these equations have no solution. So we are saying 3k plus 1 over k square plus 1 should be equal to 3 over k minus 2 should be not be equal to minus 2 over minus 5. So when we are solving these two equations, we are getting it is 3k plus 1 into k minus 2 should be equal to 3 times k square plus 1. When we multiply these equations, we get it is 3k square minus 6k plus k minus 2 should be equal to 3k square plus 3. K square get cancelled, and we are left with this k is equal to minus 1. Next, when we are talking about these two equations over here, we are saying 3 over k minus 2 should not be equal to 2 over 5. These two negative signs get cancelled. So what we are saying is that 15 should not be equal to 2k minus 4. So we get it is that 2k should not be equal to 19, implies k should not be equal to 19 by 2. So we are saying k should be equal to 1, k should not be equal to 19 by 2. So k is equal to 1 satisfies this condition also. So we are saying the given system of equation has no solution when k is equal to minus 1. Next is find the value of k for which the following pair of linear equations has no solution. So we are writing the conditions from this, that 3 over 2k minus 1 should be equal to 1 over k minus 1 should not be equal to minus 1 over minus 2k plus 1. So these two minus sign, these gets cancelled. So when we are solving these first two conditions, we are getting it is 3k minus 3 that is equal to 2k minus 1. So we get k is equal to 2. When we are looking at this condition over here, we are getting it is 2k plus 1 should not be equal to k minus 1. So we get k should not be equal to, it is minus 2. K should not be equal to minus 2. So we are having that for k is equal to 2, we are saying that a1 over a2 will be equal to b1 over b2. And for k is equal to, if k is not equal to minus 2, k should not be equal to minus 2, then the third condition is also satisfied. So it means this condition is satisfied over here. We are saying when k is equal to 2, then we are saying k is not equal to minus 2. It means this condition is satisfied over here. So what we get is that the given system of equations will have no solution when k is equal to 2. Now in this given question, we are given two equations. One is kx minus y minus 2 is equal to 0. Second is 6x minus 2y minus 3 is equal to 0. So we are saying for this system of equation to have unique solution, the condition we have is that k over 6 should not be equal to minus 1 over minus 2. So this gives us that k should not be equal to 6 by 2, that is equal to 3. So for the first case, we are having the answer, the given system of equation will have a unique solution when k is not equal to 3. We are saying k is not equal to 3. Next we are saying this system will have infinite solutions if k by 6 is equal to minus 1 by 2 and these are not equal to minus 2 by minus 3. So from these two terms we are getting k is equal to 3 from these first two terms we are talking about. First two terms of this equation, we are getting k is equal to 3. Now if we consider this first and last, we get it is k by 6 should not be equal to 2 by 3. It means k should not be equal to 2 by 3 into 6 equal to 4. So we are saying k should not be equal to 4, and it is already satisfied over here. So what we get is the given system of equation will have no solution when k is equal to 3. We are having this condition now that when k is equal to 3, this system will have no solution. Now the last case we have is for infinitely many solutions. We are saying the condition we should have is that k over 6 should be equal to minus 1 by minus 2 should be equal to minus 2 by minus 3, and this thing is never possible. We are talking about this last condition, it is never possible. So we are saying that there is no real value of k for which the given system of equation has infinitely many solutions, because this part we are saying this is never possible. Now the next we have, it is homogeneous system of equations. So means we are talking about the homogeneous means these constant terms over here, these constant terms we are talking about, these are 0. That is the value of c1 that is equal to c2 equal to 0. So we are saying that whenever the system is homogeneous, then one solution, homogeneous equation means suppose I am saying 2x plus 3y equal to 0, 4x plus 7y is equal to 0. Suppose these equations are given to us. Irrespective of the values of these a1, b1, we are saying x is equal to y is equal to 0 is always a solution of this equation. It means first thing is clear that homogeneous system of equation is always consistent. That is, it is always having the zero solution. Zero solution means x is equal to 0 and y is equal to 0 is always the solution in this case. So we are left with only two cases. One is it has unique solution, that is zero solution is the only solution, or it has infinitely many solutions. So the condition we have over here, it is a1 over a2 should not be equal to b1 over b2 for unique solution, and a1 over a2 should be equal to b1 over b2 for infinitely many solutions. And this is given over here that the homogeneous system of equations is always consistent. Based upon this, we have this problem over here that for what values of k this system of equation has a non-zero solution. Non-zero solution means we are saying this system, I am again repeating, this system is always consistent. Consistent means we are having two cases, either it has a unique solution or it has infinitely many solutions. The unique solution in this case is always the zero solution. Infinitely many solution means it has zero solution plus others also. There are other values also which satisfy these equations. So when we are saying that it should have a non-zero solution, it means we are talking about the case of infinite solutions, and these equations will have infinite solutions if a1 over a2 is equal to b1 over b2. The value of a1 over a2, it is 3 over k should be equal to 5 over 10. These two gets cancelled, so the value of k we get it is equal to 6. This is the value of k that we obtain. So we are saying the required value of k is 6. So for k is equal to 6, this system of equation, this has non-zero solution.